Seagrass beds are marine plants that live in shallow nearshore waters. They are the only group of submerged flowering plants in the tropical and marine environment, except for one species, the Enhalus acroides. Seagrass beds support at least 172 species of fish, 46 species of invertebrates, 51 species of seaweeds, 45 species of algal epiphytes, and other marine megafaunas such as marine turtles and dugong. They also act as nutrient sinks and aid in filtration to improve water quality. They protect coastal communities by buffering strong waves, and some species are edible. According to UNEP IUCN in 2009, a healthy seagrass meadow or bed, together with mangrove forest and saltwater marshlands, are extremely effective in storing atmospheric carbon dioxide. It is up to 100 times faster than terrestrial forest, thereby mitigating climate change. The Philippines is home to 16 species of seagrass, making us the second highest in seagrass diversity in the world. They spread discontinuously over 978 square kilometers in 96 sites. Seagrasses are threatened by human-induced disturbances and declining coastal water quality. They are also the least studied among tropical coastal habitats. To protect and conserve this habitat, regular assessment and monitoring must be conducted to provide a science-based approach in management interventions. The DENR-BMB issued the guidelines to the Coastal and Marine Habitat Assessment and the Biodiversity Assessment and Monitoring System for the coastal and marine ecosystem to assess and monitor coastal habitats. For the seagrass assessment, prepare the following materials: 3 50-meter transect lines, pegs, Global Positioning System or GPS unit, quadrats, underwater camera, plastic slates, pencils, rulers, field guides, quadrat photo labeler if available. Following the fixed transect method, lay a 3 50-meter transect perpendicular to the shore. Then lay a 0.5 by 0.5 meter quadrat starting from the 0-meter mark on the right side of the transect and in intervals of every 5 meters. The encoder walks on the left side of the transect to avoid obstructing the data collection. Record the coordinates at the start and end of the transect line. Photograph the quadrat at the 5-meter, 25-meter, and 45-meter marks. Photograph interesting observations like the presence of dugong trails, high algal abundance, or presence of gastropods and other marine organisms. Label each quadrat during photo documentation. Provide codes for the site, transect, and quadrat. The assessment and monitoring of the data collected helps us identify the percent seagrass cover, the seagrass species composition, canopy height, epiphyte cover, algal percent cover, other features or organisms observed in the quadrat. Observe the sediment composition of each quadrat. Describe the grain size and texture of the sediments. Sediments are either mud, fine sand, sand, coarse sand, or gravel. Measure the percentage of seagrass cover. Use calibration sheets to estimate the cover and the readings per quadrat. To minimize human errors, assign one reader to consistently read all quadrats. Identify the seagrass species present in the quadrat. Identification is easy because seagrass species are morphologically distinct from each other. Measure the species composition. The percentage of seagrass is estimated in comparison to the other species. The total seagrass composition must always equal 100%. Measure the canopy height. Get 3 measurements of the most dominant strapleaf species. Ignore the tallest 20% of its leaves. The canopy height provides a general picture of the average seagrass growth. This indicates how well the seagrass area dissipates the wave action and stabilizes the shoreline. Measure the epiphyte cover. Its measurement is always relative to the seagrass cover. The epiphyte cover is an indicator of the quality of water in the seagrass area. High percentages of epiphyte cover may indicate nutrient loading in the water. Measure the algae percent cover by using the calibration sheets. This parameter determines the competition for space and resources between seagrass and algae. Lastly, take note of other observations in the quadrat, particularly the invertebrates and grazing trails of dugong and turtles. If possible, count the invertebrates per species. In processing the recorded data, first compute for the average of the data collected per transect, and then per station. Use the per station averages for site comparison. To get the overall seagrass condition of the protected area, get the average cover percentage among the stations. Categorical interpretation of seagrass cover is based on AMRAN 2010. To determine the diversity index, use the Shannon-Wiener Index of Diversity, wherein the percent seagrass cover is used instead of individual counts in the analysis. The Biodiversity Index category will be based by Odom, 1983. Site selection is critical in all monitoring and assessments. Randomly select one sampling station in every 25 hectares or 3 to 6 sites, depending on the patchiness of the habitat. When choosing the monitoring sites, consider the following: a relatively even homogeneous shaped area, relatively high seagrass cover compared to other assessed sites, no obvious impact of destruction or obstruction to the seagrass habitat ecology, accessibility for consistent monitoring, and the presence of dugong feeding sites. Seagrass beds are not just the ordinary grasses found elsewhere, but they are an important habitat that supports different ecosystem services in the coastal and marine ecosystem.